Hi everyone, welcome to chapter 2. So in this chapter we are focusing on organizing our data. So first chapter we kind of talked about like what kind of data we're getting, how are we going to collect it, how do we set up our experiments, and so now we have our data, we want to be able to organize it, display it nicely. So a lot of this chapter is going to be talking about graphs because those are the different types of ways we can display our data. So our first section here, we are going to be making frequency distributions and then the graphs that go along with a frequency distribution. So first, we need to talk about what a frequency distribution is. So it's basically just a table. It's going to list out all the different data and their ranges. So we kind of split them up into intervals or classes so that the data, we can easily tell like how many there are in each not category, but like each of the classes that we're splitting them up into, or each of the intervals. And so that we can kind of analyze from there, once we kind of have that all set up, what our overall distribution of the data looks like. So for today, we're going to be using some data to make this table. So we want to be able to make a table for a frequency distribution that shows the classes. So aka intervals of numbers. So think like if we wanted numbers from like 30 to 34, that would be one class. Of data entries with a frequency, another new vocabulary word. So frequency is just like how many data points were within that range. And so like a count of the number of data entries for each class. So in this example here, we are using the prices of 30 GPS systems. I know it's been a while since anybody had a GPS system because we all use our phones now, but back in the day, we had to have a separate little like device to tell us where to go in our car. So these GPS systems, there's 30 of them, and here are the prices listed out. So we want to organize this into like a nice little table. So that's why we're making a frequency distribution with it. In order to do so, here are the steps. So first we want to decide on the number of classes. So we're not really deciding, it's just going to tell us within the problem how many classes to use. So in this example, it tells us to use 7 classes. So right there, they already told us we're going to be using 7 classes. Then the next step is to find the class width. So there's a formula for this. To find the class width, we're basically saying for each of the ranges of the numbers that we're using, like how big do we want that range to be? So to find that, take your biggest number minus your smallest number, so max minus min, and then divide it by how many classes you want. So looking at our data set, we just need to find the biggest and the smallest number. And this is doable. It's not that difficult. It's just sometimes we make mistakes because we like miss a number or something. So we're actually going to use our calculator to do this. And so it'll be a little bit slow going just as we get used to using the calculator, but I want to show you how to do everything because our calculator can put all of these numbers in order for you, which saves so much time. So once you know how to do that, it'll save you a bunch of time. So what we want to do with your calculator is first turn it on. So when you turn it on, it'll pop up with a screen, possibly, I don't care about it, so just hit 2 for continue, 1 for do not show again, I don't care. To get to a spot where we can enter all our numbers, our favorite button is going to be stat, because this is a statistics class. So hit the stat button, and then you'll see this menu where you see edit, calc, test. We want the edit because we're trying to edit a list of numbers. So press enter when you have one edit highlighted. Okay, then this is where we're going to start typing in all our data values, all into L1. So L1 just stands for a list. This is list number 1. There's multiple lists that you can use, but we're going to enter numbers into list number 1. So I'm just going to start typing all my numbers in my data set, starting with 90. So type 90, hit enter, and that's how it'll save that first number. The next number is 130, hit enter, and so on. Let's pretend for some reason I typed in 4,000 instead of 400, and I'm like, oh no, this is a mistake. All you have to do to fix that is to highlight using the arrows the number that you want to fix, retype the number, so I want this to be 400 and not 4,000, hit enter again, and it'll fix it. Then the next number is 200, Cool, keep going. I'm going to pause here while I type in the rest of my numbers. Okay, so I have finished typing my list, and if you are using this calculator, the app on your computer, you can actually use the number keys to type in your numbers and the enter button to enter. So that saves you a little bit of time rather than having to click through every number. So in your list, you should be, like after you've entered in your last number, you should have a blank spot highlighted and it'll say L131. So that tells you in that list that's the 31st spot, which you have nothing in, which means the number before it, the 150 that we typed in, was our 30th spot. And that's kind of a good way to keep track of, like, did I enter in all the numbers that I have? So this will tell me that I have 30 numbers in my data set, which is true because we said we have 30 GPS prices. Okay, so I have everything now. I'm going to have my calculator put these numbers in order for me. So what I'm going to do to get out of this screen and back into like the home screen of the calculator, there's above the mode button next to the blue button, it says quit. It's in blue, so I'm going to hit the blue button first and then mode. And this takes me back to my home screen where I can do all my calculations. So from here, I'm going to go back into the stat button, but I want the list button above it. So it's in blue, so it's going to be second stat. And then it'll take me to this menu of names, ops, math. We're going to ops, so scroll over to the right with the right arrow so that ops is highlighted. Sort A is what we want. Sort A means sort ascending. So we're going to go from the smallest to the biggest number because your numbers are getting bigger. Ascending. So hit enter. And then it'll ask you which list. So it'll say sort A, parentheses. We just have to tell the calculator which list we want sorted. So we typed all our numbers into L1, so we have to type in L1. To type in L1, there's a blue L1 above the number 1. Since it's blue, second button first, and then the number 1. And then close your parentheses with the parentheses that's above the 9, and then hit enter. It'll say done. It did it. So now when we go back into our list, we should be able to see that all of our numbers are now in order from smallest to biggest. So to get back into our list again, we're going to click our favorite button, stat, enter for edit, and then now we see the smallest number that we had was 59. And if I scroll all the way down, we'll see that the biggest number we had was 450. Okay. So now let's find the class width. So my first step in making a frequency distribution, we said we wanted 7 classes. So step 2, class width, is going to be your max number, which was 450, minus the min, which was 59, divided by how many classes we wanted, which was 7. When I do 450 minus 59, I get 391, divided by 7 gives me 55.86. For our class width, after we've divided, we want to make sure that our class width is going to end up as a whole number. So here we ended up with 55.86. We're going to round this to the next highest whole number of 56. So 56 is our class width. And you're always going to round up to the next whole number. Even if we ended up with like 55.1, we're still rounding up to 56. And this is just the rule for class width. Always round up to the next highest whole number. Our next step is to find class limits. So the class limits is just basically saying, what are your ranges of numbers? What are your intervals of numbers that we're going to use for our little categories? So to start by doing that, we're going to take our smallest number that we had in the data set and write that first. So 59 was our smallest number. That's going to be our first lower limit. So the lower limit is like the first number to the upper limit to what number. So 59 is going to be our first number because that's the smallest. Then to find the next lower limit, we're going to add the class width to that number. So our class width was 56. So I'm going to add 56 to 59, and that'll give me 115. And I'm going to keep adding my class width of 56 until I get 7 numbers total. Alright, so I've done that now by adding 56 each time, and then now I have a total of 7 numbers as my lower limits. To find my upper limits, it's always going to be one number less than my next lower limit. So for my first class, it's going to be from 59 to 114, because 114 is one number less than my next number of 115. And then the next one would be 170 for my next upper limit, because it's one less than 171. And then 226, 282, 338, 394. And this next one, I'm just going to add my class width again, because I have no more numbers to look at underneath. So if I add 394 with 56 as my class width, I get 450, which also happens to be our last number in our data set, or the biggest number in our data set. It doesn't always happen this way, but it's nice when it does. So that's how we're setting up our classes. So these are our class limits of what ranges we're using in order to organize our data. So the next thing we want to find in our frequency distribution table is the frequency. So frequency just stands for, or is the counts. So we basically want to figure out for our first class of 59 to 114, how many numbers do we have in our data set that fall within this range? So it's pretty easy to do once you have all your numbers in order in your calculator, because if I scroll all the way back up to the top, I can just count. So I'm looking for numbers between 59 to 114, including 114. So my first number is 59, 70, 90, 95, 100, and then the next one after that, 130, does not fall in that range. So that is a total of 5 numbers. So my frequency for that 59 to 114 class is 5, because there were 5 numbers within that range. And then I'm just going to keep going down my list of numbers and counting how many are between 115 to 170, between 170 to 171 to 226, and so on. So these are the frequencies that I ended up with going down my list in my calculator. So it's a lot more easier to do when you have all your numbers in order. Otherwise, if you don't have your numbers in order, and let's say you were just looking at your data set like this, you can go through and just make tallies. So like 90 is within my first class, 130, which was my next number, is here, 400 is here, and then just make little tallies as you go to count up, which takes a little bit longer in my opinion, but you can. So these 2 columns right here that we've made are basically your frequency distribution. Everything else that we're going to find within our frequency distribution is just going to help us make our graphs for later. So the next thing I want you guys to be able to find is the midpoint of each class. To find the midpoint, you're just going to take the lower limit, add it to your upper limit, and divide it by 2. So for our first class, our lower limit was 59, and then our upper limit was 114. Dividing that by 2, we get 86.5. And then we're just going to continue doing this for the rest of our classes to find all of our midpoints. So here are all my midpoints that I've gotten. Hopefully you got the same numbers as I did. The next thing we want to be able to find is the relative frequency. Relative frequency is just a fancy word for percent. We're just trying to figure out of the total number of data points we have, what percent are the numbers that we have between each of our classes. So to find the relative frequency, you're always going to be taking your frequency and dividing it by the total number of data points that you have. So for us, this would be 30. So for our first class, our frequency was 5. Dividing that by our total number of data points of 30, we get 0.167, if I round correctly, which is moving the decimal place twice, gives me 16.5. 26.7%. So remember, you're always moving the decimal place twice to the right. And then we're just going to continue this. So my next frequency was 8. Dividing it by 30 gives me 0.267 if I round correctly, and that'll be 26.7%. My next frequency was 6 divided by 30 gives me 0.2, which is 20% if I move my decimal place twice to the right. And continuing on, I'm just going to find the rest of my relative frequencies. So I found all my relative frequencies. The last thing that we want to find is the cumulative frequency. Cumulative frequency just means you keep adding up your frequencies from whatever was before it. So our first frequency was 5. So we're going to start with 5. There's nothing before it, so we add nothing to the 5. Our next frequency was 8. The stuff before it was 5, so adding those two together would give me 13. And then my next frequency was 6. Adding it to everything before it would be 6 plus 13 gives me 19. And we just keep adding. So now I'm adding 5 to what I just had. Then I'm adding 2 to what I just had. Adding 1. And then adding 3. Because that was my last frequency. And at the very end, your cumulative frequency, you should end up with the total number of data points that you started with. So we had 30 data points total, and that's where I ended. So it should always add up to be that total number. If it's not, that means you added wrong somewhere. So go back and check your work. So this completes our frequency distribution table. We've got all of our numbers here. We're going to be using all of these numbers to make 4 different types of graphs using this data. So the first one we're going to make is a frequency histogram. Then the others are going to be the frequency polygon, relative frequency histogram, and the cumulative frequency graph, which is also called an ogive. So I'm actually going to start with the frequency histogram and then jump down to the relative frequency histogram because they are very similar to each other. So our first graph, the frequency histogram, is basically just a bar graph, except bar graphs are only used for qualitative data, so our histograms are used for quantitative data. And so when we make a histogram, your bars have to touch because in a bar graph, the bars don't touch. Our x-axis is going to be our data point values. So whatever your data values are, for us, it's describing the GPS prices. The y-axis is always going to be frequency, and that's why it's called a frequency histogram. So setting up our axes then on our graph, I've labeled my x-axis with GPS prices and my y-axis with frequency. So on my x-axis, the numbers themselves, we're going to be using what we call class boundaries. And so class boundaries just make sure that the bars that we have, when we label our x-axis with the numbers, that they separate the bars without any gaps. And so to find those numbers, you're going to subtract 0.5 from your lower limit and add 0.5 to your upper limit. So looking back at my class limits, my first class was 59 to 114, which means if I subtract 0.5 from my lower limit, I get 58.5, and add 0.5 to my upper limit will give me 114.5. So those are the first two numbers I'm going to use on my x-axis then. So I'm going to use this little zigzag to show that I'm going to start all my numbers on the x-axis at 58.5 rather than starting from 0 because there's no numbers less than that. So the zigzag is just called a break. It tells people like I'm starting at something other than 0. So we're going to start here at 58.5. Then the next number I got was 114.5. And I'm just going to space it out because I know I can fit everything here. So those were my first two class boundaries. Then looking at my second class, I had 115 to 170. If I subtract 0.5 from 115, I get 114.5 again, which I already labeled on my graph, so I don't have to do that again. Next, 170 is my upper limit, so I add 0.5 to that to get 170.5, and that'll be the next number I add to my graph. So 170.5. Hopefully at this point you realize that you can just keep adding 0.5 to all your upper limits now, and that'll complete the x-axis. So then the next one would be 226.5, and then 282.5, 338.5, 394.5, and 450.5. Sorry, my graph is a little squished. All right, and then our frequency on the y-axis, we just want to label the y-axis with our numbers that we can use with our frequency. So it looks like the biggest number I have is 8 for my frequencies, so I really don't need anything higher than 8. So I'll just go by ones. 1, 2. Oh, nope, just kidding. Doesn't fit. We'll go by twos. 6, 8. Okay, so our first bar goes from 59 to 114, has a frequency of 5. So the class boundaries for that were 58.5 to 114.5 with a frequency of 5. So I'm just going to make my bar right in between those two numbers. Frequency of 5 means it's going up to 5. I'm going to keep doing this for the rest of my frequencies. My next one was 8, 6, 5, 2, 1, and 3. And there's my my frequency histogram. You can color in the bars if you want to make it a little bit easier to see. You don't have to. The next graph I want to talk about is the relative frequency histogram. It's super similar to the frequency histogram. All we're doing is just adding the word relative in front of it. So the relative part just means that we're talking about percents. Like when we say like relative to something else, it's just talking about like comparing it compared to the total. So that's why percents make more sense in a relative frequency histogram. So I've set up my relative frequency histogram. The x-axis is going to be the exact same as your frequency histogram. So all the class boundaries you used in your frequency histogram, you're using the same ones here. So same numbers on the x-axis. On the y-axis, though, the only thing that changes about this graph is it's going to be the relative frequency instead. So all our percents. So looking at my frequency distribution earlier, in my relative frequency column, the biggest percent I had was 26.7, so I went up to like 30. So I labeled that here on my y-axis, and then here we go. Let's draw our bars for each of our relative frequency histogram. So the first bar was 16.7%, which is just a little bit over the 15% mark. And then the next one was 26.7%. That was the highest one, which is right here. And then after that was 20% right here. And I'll continue on. So I finished drawing out all my bars. And as you can see here with our relative frequency histogram, the length of the bars are all pretty much similar to the frequency histogram. Just depending on how you set up your percents on the y-axis, they might be a little taller, a little shorter, but generally the same shape because it kind of goes up, then comes back down and goes up again. Goes up, comes back down again, goes up again. So that same shape is going to be there for both the frequency histogram and the relative frequency histogram. So these two graphs are going to be the most similar to each other. The last two that we have is the frequency polygon and the cumulative frequency graph, otherwise known as an ogive. So these two look way different. So I'll start with the frequency polygon. For this one, your y-axis is the same as your frequency histogram, where the y-axis is going to be your frequency. But we're not going to have bars in this graph. It looks more like a line graph, so a bunch of dots with a line connecting them together. Alright, so I've set up my graph with the y-axis as the frequency. So it's just going to look like the frequency histogram from before. So the same numbers on the y-axis. On the x-axis, this is where we're going to use midpoints instead of the class boundaries. So if you look back at our frequency distribution, our midpoints are all these numbers right here in the third column. And so with our midpoints, we don't start with that first 86.5 that we had. We're going to take the first midpoint of 86.5 and subtract the class width from it. So our class width was 56, so 86.5 minus 56 is 30.5, so that'll be my first x-axis label. So 30.5. Then the second one will be the 86.5 that I had on my chart. And then we continue on, so then we had 142.5, 198.5, and then we continue until we have all our midpoints listed out. So the last midpoint I had calculated out from my chart was 422.5. Then we're going to go one more and add the class width to my last midpoint. So if I take 422.5 and add 56 to it, because that was our class width, we get 478.5. So that'll be my last value on the x-axis. So for the frequency polygon, we use the midpoints, but we have to add to the last midpoint and subtract from the first midpoint. From here, because we want to show the changes of our frequencies, that's what a frequency polygon does. It emphasizes the changes between each of the frequencies. So in order to show that, our first point on our graph is always going to be at 0. So at 30.5, we're going to put a point at 0. And same thing, it's going to end at 0 as well. So at the last number that we had on our x-axis, that's going to be at 0. So then at 86.5, we start listing the frequencies that we had. So 86.5 had a frequency of 5 here. 142.5 had a frequency of 8. 198.5 had a frequency of 6, and so on. So we're just going to put dots on all those spots. So 5, oops, that's not 5. 5, 8, 6, 5, 2, 1, 3. Okay, once you have all your frequencies dotted out, then we're going to connect all of the dots together into a line. So you want to connect in order. There we go. That's our frequency polygon. So as you can see, what it's showing you is that it like increases dramatically first, then it kind of decreases, and the decreases, jumps back up just a little bit at the end, and then that's our graph. Finally, for our very last graph, we are talking about the cumulative frequency graph, or the Ogive. So it's spelled kind of funny. It looks like Ogive, but it's actually Ogive. So on our y-axis, this is where we use our cumulative frequencies that we calculated from earlier in our distribution. So right here, this last column is the cumulative frequency. That's what we're graphing out. And then on the x-axis, this is the same as before. We're using our class boundaries again, so it's basically like our relative frequency histogram or the frequency histogram where we have all the 0.5 numbers. Those are our class boundaries. So that's going to be set up the same. And then for the Ogive, just like the frequency polygon, the first point is also going to be on 0. So at 58.5, we're saying there's no other frequencies before 58.5, so a frequency of 0. Then our first cumulative frequency was 5. So, and then 13, 19, and so on. So we graph the rest of the numbers. So I've set up my y-axis by 5s so that I can fit all, my total amount was 30, so that'll be the highest number that it'll need to go. So I start at 0, then 5, then 13, then 19, 24, 26, 27, and 30 is our last one. So you should always be ending on the total amount of data points that you have. Okay, once we have all our dots drawn out, we connect them with the line again. There we go. So the curve is always going to be going upwards as you go from left to right. And it's basically showing how the graph changes. So the steeper each of the line segments are, the taller the bar, because it shows that it increased by a lot. So if it increased by a lot, then there should be a taller bar if we were to look at a histogram, which is true because our second bar was the tallest. And so it's the steepest right here in the second line segment. And that's the Ogive. Those are all the different graphs that we want to be able to make with a set of data. All right, thanks for watching.